Welcome back, everyone, to another explainer. Today, we're diving into one of the absolute most fascinating and really transformative technologies of the modern internet. We hear the word Ethereum thrown around constantly in the news, right? Usually it's just attached to a price ticker, but honestly, if you view it simply as money, you're kind of missing the entire point of what it actually is. So today, we are going to explore Ethereum's true identity. We're looking at its role as a programmable foundation for the web.
Let's get right into it. Here's our roadmap for today. First, we'll meet the world computer. Then it's Bitcoin versus Ethereum, followed by the magic of smart contracts. After that, we'll take a look under the Ethereum hood. And finally, we'll wrap up with the historic merge upgrade.
All right, let's kick things off with Section 1, Meet the World Computer.
So Ethereum, often just represented by the ticker ETH, is the world's second largest cryptocurrency. It was launched back in 2015 by a programmer named Vitalik Buterin. But here is the real secret sauce. It actually functions as a programmable blockchain platform. Its core design isn't just to, sit in a digital vault somewhere. It was built from day one to be programmed, customized, and built upon by developers all over the globe.
And that programmable nature brilliantly illustrates exactly why it earned its famous nickname, the world computer. Seriously, I want you to completely detach Ethereum from the whole concept of a traditional coin for a minute. Instead, think of it like a giant, decentralized, global computer. It's essentially a shared mainframe, but it doesn't live in one massive corporate server farm. Instead, it's maintained by thousands of participants globally. And because there's absolutely no hard cap on its supply, its economy actually functions dynamically to support this massive computing network.
Moving right along, let's hit Section 2, Bitcoin versus Ethereum.
There's a pretty stark contrast in purpose here, and this is where people often get confused. So Bitcoin was created by Satoshi Nakamoto back in 2009 to basically be digital gold, right? It's a pure currency with a strict hard cap with 21 million coins, and it operates on a system called proof of work. Ethereum, on the other hand, created 6 years later in 2015, is a programmable platform. It has absolutely no hard cap, it uses proof of stake, and it has these things called smart contracts built right in. To put it simply, if Bitcoin is like a simple, highly secure pocket calculator designed to do one specific thing flawlessly, Ethereum is like a modern smartphone. It's a dynamic platform designed to run basically countless unique applications.
Which brings us to Section 3. The magic of smart contracts. Now, a smart contract isn't actually some boring legal document you sign with a pen. Not at all. It's simply a self-executing program stored directly on the blockchain. Basically, once the predetermined conditions are met, the program just automatically runs. That's it. It requires no middleman, no manager, and zero oversight. And crucially, this is important, once it's deployed to the blockchain, it cannot be changed. It runs exactly as programmed every single time without fail. To really make this concrete, let's look at the logic. Think of it functioning exactly like an unstoppable digital vending machine. It goes like this. IF, John sends 1 ETH, then automatically send him 100 tokens. It is simple, highly precise, IF, then logic. You don't need a clerk there to hand you the tokens, and you definitely don't need a bank to process the transaction. The code itself acts as the trusted executor. How cool is that? So you might be wondering, what actually happens when you stack thousands of these smart contracts together? Well, you get an entire ecosystem. Because of these self-executing programs, Ethereum powers DeFi. That's decentralized finance, which means you can borrow, lend, and earn interest on crypto with absolutely zero banks involved. It also powers NFTs, enabling verifiable digital ownership for things like art, gaming items, and music, right there on the blockchain. And it powers dApps, or decentralized apps, like Uniswap, OpenSea, and Aave. These are apps that function just like the ones on your phone, except no single company controls them. Let's look a bit deeper in Section 4, under the Ethereum hood.
Okay, so the really crucial point here is understanding this linear sort of assembly line of operations. First up, developers write the smart contract code, and they deploy it right onto the blockchain. Second, to actually run that code or to make any transaction at all, you have to pay a small fee. This is known as a gas fee, and yep, it's paid in ETH. Think of ETH literally as the fuel that's required to power the network's engine. And finally, step 3, the network uses a system called proof of stake to validate these transactions and keep the whole blockchain secure. And because of this specific architecture, the ETH token itself has massive real-world utility within this bustling network. Like, you aren't just holding it to blindly hope the price goes up, you actually need it. It's used for paying those required gas fees we just talked about. It's used as collateral for lending and borrowing in DeFi. It's the actual currency you use to buy and sell NFTs. And it's even used as a voting weight in decentralized organizations. The token is literally the lifeblood of the entire ecosystem.
All right, moving to our final section, Section 5, the historic merge upgrade.
This was an event known as the Merge, and let me tell you, it was a massive technical shift that happened in September 2022. Before the merge, Ethereum used proof of work that relied on incredibly energy-intensive mining, much like Bitcoin currently does, requiring massive amounts of computing power and electricity. But after the merge, the network successfully switched to proof of stake. So instead of burning huge amounts of electricity to validate transactions, validators simply lock up their existing ETH as collateral to secure the network. It completely shifted from an energy-heavy hardware process to a highly efficient software process. And the result of that massive architectural shift? A 99.9% reduction in energy consumption. I mean, 99.9%. That is a staggering statistic. By simply upgrading its consensus mechanism from mining to validating, Ethereum virtually eliminated its environmental footprint practically overnight. It made itself a truly sustainable foundation for the future of the internet. Which really brings us to our core takeaway from this entire explainer. When you look past all the price charts, all the market hype, Ethereum is exactly what it set out to be back in 2015. It is the programmable backbone of the entire crypto ecosystem. It is the core decentralized infrastructure making smart contracts, DeFi, NFTs, and dApps a working reality today. We've seen how this incredible global platform evolved from a simple white paper into an ultra energy efficient network powering literally billions of dollars in decentralized applications. The foundation has been laid, the gas is in the engine, and the code is self-executing. So the only question left for us is, what will you build on the world computer? Thank you so much for joining me on this explainer today, and as always, keep learning.